So at least the pink. All right, so if you have a set of something, like you have a set of cards, it's plural. So if you're giving me a domain, you should be giving me more than one number. So when we do interval notation, which is pretty much all we have done in this class, you got to give me at least 2 numbers. So anytime you give me an interval, you have to have 2 numbers. If not, then it's not correct. All right, so if you were paying attention last week, me and Mr. Kim talked about how polynomials, which is what you guys did a project on, all of those have the same domain, which are called, we say all real numbers. But if I say all real numbers, that means I can be anything. So if I can be anything on the negative side, what do we normally write if I can be negative forever? Negative infinity. I can be any positive number, so that's going to be positive infinity. And infinity symbols always have the parentheses. They are never brackets. They have never been brackets, never going to be brackets. They are parentheses. So last unit was everything polynomials. This unit we're doing things that are not polynomials. So everything inside that table, make sure you know it's not a polynomial. And we're going to talk about the domain. So for the first one, it's 1 over x. And we can never, ever, 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 ever divide by 0. Because division is grouping. So if you're telling me you're dividing by 0, you're telling me you divided something into 0 groups. Well, if you have 0 groups of something, that's nothing. So you either have one big group or you have small groups.
Wait, she ain't there yet. I got to write.
I like Coke, but I want you to go to practice.
I got you.
Go to practice.
If they don't have it, I'll do it.
Dr. Pepper?
I got you. Mike Ice, right?
Pretend like I know nothing. Okay, so if x cannot equal 0, that's the only thing I'm not allowed to be. I can be anybody else. So what kind of numbers are less than 0? Negative numbers. If I can be any negative number forever, I say what? Negative infinity. So we go from negative infinity to 0. So I'm going to draw this space for you, and if you don't remember it from way back when, like the beginning of November, I would draw it a few times for yourself. So if you would use a less than symbol or a greater than symbol, that's an open circle. That means you're less than something or greater than something. You use parentheses. If you think less than or equal to, greater than or equal to, emphasis on the word equal, that's a closed circle and it's a bracket. So if something is not equal, you have to use parentheses all the time. If it is equal to it, that's the only time I should see a bracket. So that piece I just wrote says I can be any negative number all the way to 0, but I can't be 0. I could be 0.1111 or negative 0.99 blah, blah, or negative 0.111, but it can't be a 0. So I can be numbers less than 0. I could be numbers greater than 0. What kind of numbers are greater than 0? Positive numbers. So that's going to be 0 to positive infinity. So that's how mathematicians will tell you I skip over 0. So the U, just like for your project, stands for union. So I can be any negative number, any positive number, but I can't be 0, which hopefully we know 0 is neither negative or positive, right? It's neither. What the heck? All right, so for the middle person, what is that guy called? Something x. What am I doing to x? I hear it. Starts with an S, square root. And so what numbers do we not like to take the square root of? So we introduced a letter last unit called I. And when did we get I? When it was negative. So we don't care about things that are imaginary. We care about things that are real. And so the only way you're going to get a real number is if you have positive numbers. So that's why the second one says x is greater than or equal to 0. So if you look at the faces that I drew, that greater than or equal to symbol gives me a bracket. And then what's nice about inequality symbols is inequality symbols have arrows, right? The top part, the actual symbol itself is an arrow. And which way is this arrow pointing? To the right. If you think of any kind of graph, the numbers to the right are positive. So if I go in the positive direction forever, what do I write? Positive infinity. Or you could just think about it logically. Numbers bigger than 0 are positive. Okay, so then the last piece is 1 divided by the square root of x. So you still can't divide by 0, but you can't take the square root of a negative. So that's why it's now x is greater than 0. And so because I'm strictly greater than, not equal, it's 0, parentheses, parentheses, infinity. So I would draw those faces over and over and over until you remember, like, oh, I use a parentheses here, but I use a bracket here. Because if you reverse them, it is wrong. And I will not give you the points because it's wrong. So let's do some examples. So the first example, and these, I would not take a lot of space for these. So don't take up too much space. You'll need more space towards the end. So number 1 says 4x divided by 3x minus 5. Does that look like the top example in the table, the middle, or the bottom? So which example from your table does number 1 look like? The top one. And the top one said x cannot equal 0. So when it comes to fractions, when we start talking about domain, we only care about the bottom. So whatever makes the bottom 0 out is going to make me unhappy because we cannot divide by 0. So you're going to use that table to help you do all of your domain problems. You're going to tell me 3x minus 5, and just like in the table, you're going to write does not equal 0. Because that's the example that it looks like. If it looked like the middle, you would put the greater than or equal to 0. If it looked like the last one, you would put the greater than 0 piece. So you have to find the pattern. So it's one of those 3. Even though it has that slash through the equal sign, which means not equal, we solve it the same. So how do I get rid of the minus 5? Add 5, so we get 3x equals 5. How do I get x by itself? Divide by 3. So that tells me x cannot be 5/3. And leave it as a fraction. So any answer key is going to have the fraction, and never going to put a decimal. So you don't have to check, but I'm just going to show you why the answer can't be 5/3. So if I plug in 5/3 to the bottom, it'll be 3 parentheses 5/3 minus 5. What happens with my 3's? They cancel out, because technically this is 3 over 1, and I can cancel. And I get 5 minus 5, but that's what? 0. So if I plug in a 5/3, I make my bottom 0. We can't do that. You can't divide something into 0 groups. It's not logical. Okay, or put it on the calculator, it'll give you an error. So that's the value that I can't be for my domain, but I can be anybody else. So anything less than 5/3 forever. So that's going to give me negative infinity to 5/3 union 5/3. And 5/3 is already positive, but I can be anybody bigger than that forever. So what do I write if I'm going to be forever in that direction? So what should I write? Should I write 10? What am I going to write? Positive infinity. Because I can be anybody else. No one really cares what it is, as long as it's not 5/3. Okay, so example 2 is also like the top piece, because there's no square roots. So we just have to figure out what's going to make the bottom value 0, because whatever that is not going to make me happy. So we're going to have x squared minus x minus 6 can't equal 0. How many terms does that bottom piece have? 3. And what's the highest power? 2. You got to factor. So what factoring method can I use? X method. So I'm not going to go really slow on X method because we practiced on Friday, and I've been trying to get some of you to pay attention for like the past month and a half. So this coefficient is 1. It's always A, which in this case is 1, times C, which is negative 6. So I need two numbers that multiply to negative 6, but when I add them together, give me negative 1. So it won't be 1 and 6, right, because that's only going to be 5. So what else multiplies to 6? It's a 3 and a 2. So which one's positive and which one's negative? 3 is negative and 2 is positive. So the first person, just like on Friday, stays the same. So it's x squared minus 3x plus 2x minus 6, and then you group them. So out of x squared, negative 3x, I can take out an x, so I get x minus 3. Out of 2x and negative 6, I can take out a positive 2. And so I get x minus 3 for both, which makes me happy, because if I didn't, that means something went wrong. So I put the x and the plus 2 together, and the x minus 3, and we have not equal 0. So just like last unit, you take each piece, x plus 2, say that guy does not equal 0, and you take x minus 3 and say that that guy does not equal 0. So how do I solve the one on the left? We subtract 2, so that tells me x cannot be negative 2, and the other one says x cannot be positive 3. So some of you might find some patterns to make this go faster. Just make sure you pay attention that the coefficient on those x's are 1. Okay, so what number's smaller, negative 2 or 3? Negative 2. So I can't be negative 2, but I can be anybody smaller than negative 2 forever. So the moment I say forever, and I'm talking about negative numbers, that should make us think negative infinity. So I can be negative infinity to negative 2, but I can't equal negative 2. That's why it's a parentheses. I can't be negative 2. What's the other number that I can't be? 3. But I can be anything else. What's a number in between negative 2 and 3? Net like 2.5, 1, 0. I can be any of those people. So my next one is negative 2 to 3. And then how would I write the last one? So I can be any number bigger than 3. So what would I write to say I can be anybody bigger than 3? So what number goes first? 3, and then positive infinity. So the more numbers that you're not allowed to be, that gives you more intervals. So that's why I have 3 different pieces. So I can be anybody less than negative 2, that's the left. Anybody between my 2 numbers, and anybody bigger than the last person. All right, so for number 3, we have the square root of x minus 8. So does that look like the top person, the middle person, or the bottom person from that table? The middle. So that one said x had to be greater than or equal to 0. So that's exactly what we make our particular problem, greater than or equal to 0. And then you solve for x. So how do I undo a square root? We square it. So a square root and a square cancel out, and we're left with x minus 8. What's 0 squared? Is still what? 0. And then that's easy enough to solve, right? How do I get rid of subtract 8? Plus 8. So that tells me x is greater than or equal to 8. So what kind of numbers are bigger than 8? What's a number bigger than 8? 9, 10, 11, 12, 100, 200. So my smallest number is 8. If it's a greater than or equal to, that's a bracket. If I can be any number that's bigger than 8 forever, are these numbers going to be positive or negative? Positive, so it's going to be positive infinity. Okay, again, the moment it's a fraction, I really only care about the bottom piece. So this last example looks like the bottom of that table. So we're going to have the square root of 4x minus 12 is greater than 0. How do I undo a square root again? We square it, and we know 0 squared is just 0. So we get 4x minus 12 is greater than 0. What do you guys want to do first to solve this? So we're going to take care of that subtract 12 by adding 12. So we get 4x is greater than 12. And then what do we do? Divide both sides by 4. And that tells me x is greater than what? 3. So I'm greater than, bigger than, whatever, 3. So I know I have a 3. That's already a parentheses because I didn't say the word equal. It's greater than 3. If you see an arrow, you should automatically think infinity. The question is what kind of infinity? Positive infinity, because my numbers are greater than a positive 3, so it must be positive forever. Alright, so we're going to simplify. Now that we've reviewed domain, we're going to simplify. So the first example is 65, a to the 4th power, b to the 2nd, divided by 100, a to the 5th, c to the 3rd. So hopefully this looks a little familiar because you do a little bit of this in math too when they teach you about exponent rules. And if not, we did it this year. And so remember back in August, I kept stressing those exponent rules because I know it's going to come up a lot. Okay, so what can I divide both 65 and 100 by? 5. So 65 divided by 5 is 13. I'm going to leave the letters alone for now. And then 20 times 5 is 100. So 100 divided by 5 gives me that 20. So if you know your exponent rules, you're going to be able to skip the work that I'm about to do at the bottom. So if you don't remember your exponent rules, to simplify my a's, which is a4 on top and a to the 5th on bottom, you would have to write down a times a times a times a for the top. How many a's do I need on bottom? 5. So then every a that they have in common, I can do what? Cross them out or cancel. Cancel or cross. Okay, so 1, 2, 3, 4 is gone. How many am I left over with? 1 is on top or bottom? Bottom. If you knew the rules, you always just subtract the numbers. So 4 minus 5 would have given me a negative 1. And because it's negative, that tells me it should be on the bottom. So however you want to do it. So I have 13. Didn't do anything with B. 20. A. Do I have to write that 1? So I have to put A to the first? No. c squared. So are b and c the same letter? No, so that means I can't simplify anymore. They have to have the same base. So in this case, talking about letters, that means we can't do nothing else, so we're done. So 13b squared, 20ac squared is our final answer. Okay, so number 6 says 12x cubed y z to the 5th divided by negative 10x y squared z cubed.
How'd you get C squared?
Oh, did I copy it wrong? 'Cause I wrote it down wrong.
Wait, that's your
So
It's cubed.
C cubed, right?
Yep. So what can I take out of both 12 and negative 10? Or I can divide them both by 2. So 12 divided by 2 is 6. So I have 6x cubed, y, z5. Negative 10 divided by 2? Negative 5. And I have x, y squared, z cubed. So this time I'm not going to do it the long way. So I have 3 x's on top. How many on bottom? 1. So 3 take away 1 gives me how many? Gives me 2, and there's left over on the top. I have how many y's up top? 1, and I have 2 on the bottom. So they have 1 in common. That means I could take 1 away. Where's my leftover y going to be, on top or bottom? Bottom. So it's negative 5y. And then I have how many z's on the top? 5, and I have how many on the bottom? 3. So 5 take away 3? 2. Should it be on the top or the bottom? So which one had more? The top, so it's going to be at the top. So whichever one had more is where all the leftover always goes. So it's 6x squared, z squared, over negative 5y. So however many steps you want to do is going to depend on you. So I probably would have just jumped from top to bottom. I wouldn't have done this step for myself personally. So if you want to just go there because you can do the subtraction and the division in your head, that's fine. All right, so we've already done this, but now we're going to give a definition to it. So make sure you copy this down. An excluded value is any number or numbers, could be plural, that make the value of the denominator equal 0. So which part of my fraction is the denominator? Top or bottom? Who's the denominator, guys? Top or bottom of a fraction? Oh, Lord, guys. The denominator is the bottom. Don't scare me like that. So I only really care for excluded values when the bottom is equal to 0. Nobody cares for the top in terms of excluded values. So this makes the value undefined because you can't divide by 0 ever. Ever, ever, ever. Okay, so it is always the factors before you simplify. So before you start canceling stuff out, because a lot of people get cancel happy, they just start crossing crap out. Before you do that, you have to have already done your excluded value. So before. So before you simplify, find your excluded values. And you'll see what I mean in a second. Okay, so if you run out of space, just take out a piece of paper. So I'm going to do 2 more examples with you, and then there's one example that you're going to do on your own, then I'm going to call on people. Okay, so while some of you finish up, this unit is heavy factoring. So like the prerequisite skill for this unit is factoring. So that's why on Friday, that pink paper that I have, that if you didn't turn it on Friday, you should give to me, said Unit 4 prereq skills. So going in, you gotta be able to factor. So some of you, if you don't practice your factoring, that part, which is not supposed to be the long part, is gonna take you longer than I'm expecting it to. Okay, so you gotta practice your factoring. Alright, so while some of you finish up, what's the opposite of exclude? Include. So if someone doesn't include you in something, that means they left you out. So we're talking about the X values that no one cares about. They didn't get invited to the party or whatever. We skipped them.
That's basically how
Alright, so we're going to find the excluded values first. So I'm going to underline or box that in purple. So whatever I'm writing in purple, that's to find the excluded value. So we said the denominator is the bottom part of our fraction. So we're talking about n squared plus 3n minus 40 cannot equal 0. But unfortunately, that has how many terms? 3, and the highest power is 2, which means I can and have to do an x method. So the coefficient in front of n squared is 1, that's a, and c is negative 40. So I need two numbers that multiply to negative 40, but when I add them together, I get positive 3. So what multiplies to negative 40, but when you combine them together, it gives us positive 3. So I agree it's 8 and 5, but which one has to be negative, the 8 or the 5? So the 5 is going to be negative. So it's positive 8, negative 5. Okay, and this is a step that I'd recommend that you don't skip. A lot of you want to skip the step where you rewrite, and it's fine in some cases, but not in all. So n squared stays the same. I do plus 8n minus 5n minus 40. So the front person and the last person, they always stay the same. You rewrite the middle person using these numbers because 8 minus 5 is 3. So 8n minus 5n is 3n. So all I did was rewrite the middle person. So from there, I have 4 people now, and I group. So n squared and 8n, I can take out an n. So I have n times n plus 8. And when you're doing grouping, if the first person in any group is a negative, I always factor out a negative. It just makes life easier. So negative 5n and negative 40, I'm taking out a negative 5. And then I'm left with n plus 8. You put the outside people that are lonely together, right? The n minus 5 and the n plus 8. So all we did was factor. So this piece is what needs to be faster, because you don't want to spend too much time doing that or get too frustrated with that, because that's the part we've been doing a lot. So n minus 5 times n plus 8 does not equal 0. Once you're factored, you say n minus 5 does not equal 0, and you say n plus 8 does not equal 0, and you tell me what are both of those when you solve for n. So the first one on the left, what do I get when I get n by itself? So we do positive 5. So n cannot be positive 5 or, what's the other one? Negative 8. So these are my excluded people. So they are not invited to your party. We said nah.
Can you just write the opposite of what's in the parentheses?
Yep. So if your coefficient on n is a 1, once you get n minus 5 and n plus 8, Jesus, notice you can just write the opposite. So minus 5 is positive 5, plus 8, negative 8. So now we're done with the bottom. We got to go to the top. So how many terms were up top? 3, and the highest power is still 2. So here we go again. So A is 1, C is negative 56. So I need two numbers that multiply to negative 56. What's the coefficient on my B? 1. So I need two numbers that multiply to a negative 56, but when I combine them together, give me a positive 1. So 7 and 8, which one's positive and which one's negative? So the 7 is negative. And then we rewrite it, so we have n squared minus 7n plus 8n minus 56. This is my top person. So out of n squared and negative 7n, I take out an n, so I get n minus 7. Out of 8n and negative 56, I could take out a positive 8. So I still get n minus 7. What do I do with the n and the positive 8? We put them together. So I have n plus 8 times n minus 7. So that's when I factor the top. So the top piece, when you factor it, is n plus 8 times n, and that's a 7. So that's 7. So instead of having n squared plus n minus 56, I have n plus 8 times n minus 7. So I'm going to put it back in my fraction. What did the bottom factor to? So when I put it apart, what did my bottom piece factor to? N minus 5 and n plus 8. So you can only cancel if you see parentheses. So if you have n squared plus n minus 56, I can't cancel nothing. But now that I have a bunch of parentheses, what's the same on top and bottom? The n plus 8. So now I'm happy because I can go bye, bye. And whoever is left over is my simplified answer. So if you can't factor, you're not going to be able to get to this part. So you factor, and then whatever factors they have in common, they go away. You kick them to the curb, they lead a party, I don't know. They're gone. All right, so let's do number 8. So number 8's a little nicer. We have less people. So do I have anything with 3 terms on number 8? No, so that means there's no X method. So the X method problems are going to be the longest. So to find the excluded values, it's whatever makes the denominator equal 0. But before you do that, it's always easiest to simplify first, or at least factor out first. So not simplify, but factor. So what can I factor out of 10n and negative 20? They have a 10. So this is 10 times n minus 2. We only really care about this piece, the n minus 2. So this is where if you are paying attention to that trick that Jesus told you earlier, you don't need to show me n minus 2 does not equal 0 and tell me that n cannot equal what? 2. So if you factor out the number, it'll be much faster than if you do 10n minus 20 does not equal 0 and then add 20 and divide by 2. You're going to get the same result, but if you factor first, a lot of you will be able to tell me the excluded values way faster. Okay, so then for the top piece, what can I take out of both 6n squared and negative 12n? We can take out 2. We can go bigger, though. 6, just a 6. So we can take out 6n. So if I take out a 6n from 6n squared, I'm left with n. If I take out a 6 from 12, I have a 2, and the n goes away. So what can I do with my n squareds? They could cancel them out, and I have 6n divided by 10. Is that fully simplified?
Nope.
Not quite. What else can I divide both 6 and 10 by? 2. So 6 divided by 2 is 3, and 10 divided by 2 is 5. So binomials are way easier. The x method takes you a little longer. All right, so you're going to do this one with your group, and I'm going to call on people. So it's 3n squared plus 13n minus 10, and then 6n minus 4 on the bottom. So find the excluded values first.
You could factor out the 2. Yeah. 2 would be 2 parentheses. If it's simplified, if it gets simplified, it's better. The bottom's done. Like this, you can't do anything else. Yeah. And then now you have the top. And the top again, because since you have to add these two. That's fine. Yeah. 10 and 3 verse, but kind of would.
Is that
Thank you, Cece.
so you're saying for the bottom one has yeah, but you're 30.
Like it's ultimately gets simplified, do that first, and then